This is section 4.2, maximization. So in section 4.1, we learned about setting up the problem, and now we're going to use the simplex tableau to solve the problem. And the notes really just consist of some steps that you should use and that you should remember. So number 1, you want to determine the objective function in the problem. 2, write the constraints. 3, turn the constraints into equations. 4, set up the initial tableau. 5, you're going to locate the most negative indicator at the bottom. If there's 2, you choose the farthest left. Number 6, you're going to form quotients to find the pivot. The smallest non-negative is the pivot. If all fail, there is no max solution. If 2 are equal, and the smallest, you choose the one nearest the top. You change all the numbers in the pivot column to 0, and you'll do that by row operations. And number 8, if the indicators end up all positive or 0, that's the final tableau. If not, you repeat starting at number 5. So keeping that in mind, let's go look at the problem. So number 1 says the initial tableau of a linear programming problem is given. Use the simplex method to solve it. So we were given this blank simplex. We're giving the initial tableau here. I've done some little highlighting and things that you might want to do when you're working with it. And so they're asking us to find the maximum and what x1, x2, x3 are, and they've given us S1 and S2. All right, so we want to go to the first column with the most negative indicator, and so that's what we're going to do first. So we find negative 50 is the most negative there, and then we'll use an entry in the second column as a pivot, so it's going to be one of these. We need to compare the ratios of 8 and 2 and 10 and 10. We do that, we find the quotients of the constraints and coefficients in that column. So 8 divided by 2 is 4, 10 divided by 10 is 1. We'll choose the smallest quotient and use it. So second row, second column, I've circled it, that's our pivot. Okay? Now we're going to use row operations to get new tables. We're going to try to make these two items zeros. That's what we need to work on. So if I do negative 5 of row 1 plus row 2, that's going to give me a new row 1. Okay? And as you're looking at this, these are my new rows. So when I say that this happened, this is my new row 1. This is my new row 3. 5 row 2 plus row 3 gives me a new row 3. So if you go back up here, that was what I started with. Okay? And then when I do, so I'm showing you one row operation at a time. So this one really should be moved down. Okay, so I drew that arrow in to show you that. So I've got this new row 1 and I've got this new row 3 now. Now what happened, what I worked on was to make sure I turned the initial tableau, turn that 2 into a 0 and turn the negative 50 into a 0. Whatever you've got to do that. So you can see here, if I multiply that by 5 and add it to this, then that's going to turn into 0. So that was the goal there. You always want to have other 2 be 0 and your pivots there. So now you can solve. This is a solution. So 10 x2 is 10 divided by 10, which is 1. And x3 is 0, x1 is 0 because we don't have anything there. And z is 50. All right, so if we go back up here, but we didn't have to do that. We did have to get the 50, sorry. So the z was 50, and we solved for the 0, the 1, and the 0 there. So write in your little x1s above. You may have to write the tableau several times to make it work for you. and but your goal is always to take that pivot, turn the other two into zeros. Okay. All right, let's look at number 2, and I think we only have 3 of these to do. So this is the initial tableau again, and we're going to solve by the simplex method. And the furthest negative, if we are looking here, the furthest negative is -2. So this is the column that I'm going to be working on. And I do the quotients. So I have 12 divided by 1, 4 divided by 2, 4 divided by 1. The 4 divided by 2 is the smallest, so I am going to pivot right here. Okay? I started knowing this was the column I needed to work with, then I figured out the pivot. I did my row operations, and I've written them here. You might practice that, but you know, if you look at your initial one, if I want that to be 0, -2 times that gives me a -2, and then if I add it to this one, I get 0. So I've got a new row 1. That's what happened there. And then if I multiplied -2 times row 3 and added it to that, I would get 0 as well. So I did that to get a new row 3. And then I did something to get a row 4 0 as well. Once I've got that, then in my x1 column, I have 4 divided by 2, so x1 is 2, x2 is 0, my max is 4, so let's see what they asked. Yes, the max is 4, x1 is 2, x2 is 0. All right. And then we have this one. Now we aren't given a tableau here, so we've got to figure one out. This is a large problem, a lot of work in this one. That's why we only have 3. But we start out and we are maximizing this. These are my constraints. So I have to make my constraints, putting in my slack variables. So I've got 5, x1, x2, s1 equals 80. This one S2 and it equals 100. This one plus S3 equals 90. Then I make my initial tableau. X1, X2, S1, S2, S3, Z, and my constants. All right. The most negative is -9, so I'm going to pivot in this column. The quotients are 80 divided by 1, 100 over 2, 90 over 1. The smallest is 50, so I'm going to pivot here, okay? All right, so then I went through the row operations, and I'm not going to do each of those for you, but you can see that. You have it in your lecture notes. And we get down to, where are we? So we've solved and we've gotten everything into zeros except this 2. So my max is going to be 450. And x1 is 0, x2 is 100 divided by 2, which is 50. So again, our goal was to get all zeros, and our pivot was still there. So let's see what it was asking for in our original question. Okay, x1 was 0, x2 is 50, and z equals 450. So it may take you a little while to practice on that, but hopefully having those examples will help you get through that.